So in this example, we're going to want to find the distance from the point A, which has coordinates -4, 6, to B, which has coordinates 4, 2. Now, you don't necessarily need a coordinate plane for your notes, but what I want you to see is that you're looking for the distance from -4, 6 to 4, 2. So if we were to draw a line between those 2 points, how long would that line be in units? So if you haven't gotten a Keystone formula sheet, you'll be getting one pretty soon. And if you look on this formula sheet, you can see the distance formula right here. So you may want to take a moment to copy that down. I'm going to zoom in for you just a bit. And if you want to pause the video for a moment, you can. So if you want to pause the video again to write down the original problem, feel free to, but I'm going to get started. So this problem is again dealing with sets of coordinates where we've got these x1s, x sub 1, and x2. Y, by the way, if anyone ever says sub just means below, as in a submarine. If we say x sub 2, we're talking about a little 2 below as opposed to a little 2 above. So sometimes people say x sub 2 minus x sub 1. But anyway, let's set this up. So each set of coordinates is a set of x and y. So if you want to do this to help you keep things straight, it's probably a good idea. Doesn't matter which set we call the first set, but if we're going to go in this order, we could call this the first set and this the second set. So then we follow the formula. Distance says take the square root of. And I'm going to get set up here, and it says take the square root of, in parentheses, x sub 2 minus x sub 1. That's x sub 2 minus x sub 1. That should be 4. Take away -4. So we go like this. Plus. And then we're going to do y sub 2 minus y sub 1, which should be 2 minus 6. So now all we have to do is just continue to simplify this. We've got 4 minus -4 becomes 4 plus 4, which is 8. That still has to be squared. And then you have 2 minus 6 is -4, which still has to be squared. And from here we keep going. We've got 8 squared, which is 64. Now when you get to this spot where you have a negative being squared, that's always going to become positive. Sometimes people put this in their calculator as -4 to the second, and then they get out -16. But if you look carefully, that's not what this says. This says take -4 and multiply it by itself, which gets you a positive 16. So if you're going to put this in your calculator, make sure you do -4 squared in your calculator so that you get positive 16 out. You really can't square a negative and end up with a positive, because when you multiply a negative by a negative, you get a positive. Anyway, we keep going. 64 plus 16, that's 74 and 80, right? So now you're in a spot, does the teacher want an exact answer or an approximate answer? If they want an exact answer, you keep it in radical form and you simplify it. So we break this down into 80, could be 8 times 10, and 5 times 2, and 4 times 2, and 2 times 2, and then you take the pairs out. You've got a pair of 2's. Sorry, you've got a pair of 2's there, and you got another pair of 2's there. So 1 pair of 2's on the outside, and 1 pair of 2's on the outside, and then a 5 left on the inside. So 4 the root 5, and we're going to give a label of units because this is a distance and we weren't told any units, like centimeters or inches. Now, I know that I went very quickly through the radical simplifying the square root of 80 part of this problem, but that's something you should have learned in Algebra 1, and I'm happy to give you more practice on that if you need it, but it shouldn't really be in this part of the video. If a teacher wants an approximate example, so let's just mark down that this is exact, all right? So if you're ever asked for an exact answer, it would be 4 root 5. If you're looking for an approximate answer, all you need to do is put the square root of 80 in your calculator. Okay, so I put the square root of 80 in my calculator, and I'm getting a value of 8.94427. We're just going to go ahead and round that to 2 places. That's a good general rule. So we look to the first 4, and there's a 4 after it, so we're not going to round up. We're just going to keep it the same. and we can use a little approximately equal to because it's no longer exact, and we have an approximate distance of 8.94 units. So that's how you do a distance problem using two coordinates.